Okay, now we're going to talk about the metric system. So in science, we like to measure things, and it turns out that there are 7 basic quantities that from those 7 basic quantities we can build any other quantity that we want. So in our previous video, we did a problem in which we had to use the formula that the average velocity was equal to the distance divided by time. So these two terms here are fundamental terms, distance and then time, and then these are the two building blocks that can be used to generate another quantity over here, which is the velocity of an object. So these are the 7 basic building blocks in the metric system. So what's so special about the metric system? Okay, it's universal, so that everybody, all scientists on Earth use the metric system in order to communicate with other scientists. So even if you don't know English or you don't know German, you can still communicate with them by using numbers and the metric system that goes with it. Another thing about the metric system is it's based on the number 10. So the first one I want to talk to you about is going to be length, and so that's going to be the meter. So this is a meter stick, and if you're from America, you might say that this thing is a yardstick, but it's not, because if I turn this thing over, you can see the inches on it, and a yard has 36 inches, and 36 comes out to here on the meter stick, so that a yard stick is just a little bit larger than a meter stick. Don't worry about what the numbers on the meter stick are. So later we're going to talk about what those numbers are. Okay, then another quantity that is fundamental in the metric system is going to be mass, which is going to be related to the amount of matter that is inside of something. So if something contains a lot of something, it has a lot of mass. And the official metric unit for mass is going to be called the kilogram. So it's kind of unusual because this is the only metric unit that has a prefix in front of it. So you might think that the official metric unit for mass ought to be the gram, but it's not. It's the kilogram. So that's a metric prefix meaning 1,000. And so later we're going to talk about what does the word kilo mean. But to give you an idea for what a kilogram is, you can think about, if you're from America, you can think about 2.2 pounds is equivalent to 1 kilogram. They would feel the same. Another thing that you could do is if you had a 1 liter bottle. So here is a box that would contain exactly 1 liter. And you can see that it is 10 centimeters going this way. Again, don't worry about if you don't understand what the word centa means, but it's going to be 10 centimeters going this way, and then 10 centimeters going this way, and then 10 centimeters going this way. So that's going to be 1,000 cubic centimeters, which is equivalent to 1 liter. So if I was to fill this thing up with water, then it would feel equivalent to 1 kilogram. Okay, another concept. So another thing I would like for you to know is the abbreviation for each of these concepts. So the abbreviation for length is going to be the letter R. And then the abbreviation for mass is going to be the letter M. But now we're already starting to run into problems because we said that M stands for meter. So how are we going to know whether, if we have some kind of a number like 10 and then it has an M on the end of it, how are we going to know that that's not mass? Well, normally if it's written next to a number, it's going to be the unit, so 10 meters. But if on the other hand you've got something like this, so F, we're going to find out, is force, M is going to be mass, A is going to be acceleration. So if you see the M and it's with a bunch of other letters, chances are that's going to be a formula. And so that's going to be the abbreviation for the quantity mass, whereas this is going to be the abbreviation for meter. So it shouldn't be too difficult to tell the difference between the two. Okay, then you've got time, and so T, use a lowercase t, and then another thing is you might want to put a hook on the end of it so that you don't do one of these things where you might mistake that for a plus symbol. Then the official metric unit for time is going to be the second. Okay, then you got electric current. Now I abbreviate electric current with an I, and I like to use a cursive I. You don't have to, but anything that is electrical in nature, I tend to use a cursive letter to represent that. So what is electrical current? It's going to be the flow of electric charges, most often in a wire. So the more electrical charges that flow in a wire per second, the higher the electrical current is going to be in that wire. The official metric unit is going to be called the ampere, and it's going to be abbreviated with the letter A. And to just give you a rough estimate for how powerful an amp is, 1 amp is enough to French fry you. So if you were to touch a wire and you ground yourself so that that electric current can go through your body, then that 1 amp is probably going to be enough to kill you. So an amp is a fairly large unit. Okay, then temperature is going to be given by the letter T, and it's going to be uppercase T. And then it's kind of unusual because it has 2 metric units. So you might be familiar with degrees Celsius. If you're from America, you might be familiar with degrees Fahrenheit. And then this one, though, is not the official metric unit for temperature. So the official metric unit is going to be something called the Kelvin. And so that's because 0 Kelvin is going to be absolute 0. It's the absolute lowest temperature you can possibly imagine. And so that corresponds to, in Celsius, something like negative 272 degrees Celsius. So it's a very, very cold temperature. Okay, now the next one is going to be the mole. Now, in the classes I teach, I don't really use the mole that often. So in physics, we use length and mass and time and electric current, but not so much temperature in physics. But you do use temperature quite a bit in chemistry. And similarly, you use the mole in chemistry. So what is a mole? So a mole is going to be approximately 6 times 10 to the 23rd of something. Now again, don't worry about, this is called scientific notation, and that's another math topic that we'll get to. But what this means is write a 6 and then write 23 zeros next to it. That's how big a mole is. 6 times 10 to the 23rd of something. A dozen is 12 of something. A mole is 6 times 10 to the 23rd of something. So why is it that chemists like to use moles? Well, it's because in chemistry you deal in atoms. Atoms combining. And atoms are very, very, very small. So you can't take an atom and put it on a scale. It won't read anything. But what you can do is take a huge number of atoms, put it on the scale, and then it will read something. So that 1 mole of carbon means 6 times 10 to the 23rd atoms of carbon. And when you put that on the scale, then you can read something. And so in your periodic table of elements, you'll notice that there are 2 numbers for each element. So you got the number that doesn't have the decimal point, and that's going to be the atomic number, which is going to be the number of protons. And then you have the other number that does have the decimal point. That's the atomic mass. So that would be the mass in grams of 1 mole of something. So in my physics classes, we're not going to be using the mole. And for that matter, same thing is going to be true for geology and meteorology and astronomy. We just don't use it that often. But you will use it extensively if you take a chemistry course. Then the last thing there is luminous intensity, and this is going to be the brightness of an object. And in astronomy, we do deal with the brightness of stars, but we're going to use a different unit instead of this one here called luminous intensity. So again, these are the 7 basic quantities in the metric system, and then by combining them, we'll be able to come up with other quantities. As far as you're concerned, you definitely should know the letter for distance and the unit for distance, mass, time. If you're in physics, yeah, you need to know about electric current, and then to a certain degree, temperature if you're in astronomy. So it all depends on which class that you're taking. So here are some typical lengths in meters written in scientific notation, which we will talk about later. And then here are some typical time spans in seconds in scientific notation. And here are some typical masses. And so now it's time to take a break. And then when we come back, we're going to talk about metric prefixes.